Hi everyone. Welcome to the Becoming a ROS Developer YouTube channel here at The Construct. My name is Rodrigo, and today we have a student of ours, Guillermo Robledo, who is presenting us his project that he did for the course ROS2 Basics in C++, in which he controls a Turtlebot to cover the main three basics of ROS and ROS2 actually, which would be the publication and subscription to topics, the usage of services, and actions. So, hi Guillermo, how are you?
Hello, good afternoon,
Good
and
afternoon.
hi everyone in the YouTube channel.
So, so basically you're going to have around 15 minutes to present, and then I'll ask some questions. And so whenever you want, you can start sharing your screen and get started.
Okay, so I'm going to try to share the screen.
Okay.
It says it's disabled for participants right now.
Oh, let me enable it for you. Okay, you should be able to share now.
Okay, so first I would like to share how the project works inside of the construct environment. So just for a quick demonstration, trying to launch here the node.
So can you explain what the Turtlebot will be doing?
Yes, well, right now it's trying to initialize itself, so it's going to try and face the closest wall, and afterwards it's going to face with the right side of the robot to the wall, so it can try to move across the whole road with a particular distance that we have selected.
Okay.
So it's going to try to move all around the circuit.
Okay, great.
So right now it's already faced the closest wall, which was in the first image, the one that is in the bottom, and right now it's trying to move the right side to that particular wall, and apparently has already done it. This was called with a service. So right now it's just moving and trying to change direction, so it keeps a particular distance from all
From
the
the wall.
walls
Okay.
around, around the path. And apparently has I think it has detected. Oh no, I thought it just detected an obstacle as a wall, but it haven't, because um from the laser we're not, well, I'm not taking just one point uh, as as um, as data of the front. I'm taking kind of a range.
Oh, you're taking a range of values. Okay.
Yes, if for so like an angle of 10 degrees or so is what it considers the front of the robot. So it's less, well, it's a little bit more robust.
Okay, and I see it doing sort of getting away
Some,
with it, getting away
yeah,
from the wall, and then kind of correcting itself.
yeah, sometimes it takes some oscillation, but in the end, it's trying to keep a smooth path. Well, at least it's trying to. But yeah, sometimes it makes some oscillations because now it's going to turn a lot, and probably correcting that is also going to mean changing a drastic direction in the course.
Okay, and I also see that there is an output for the odometry received, which is the third part of the project in
Yes.
which you're using an action server, correct?
Yes, so after the initialization, an action server is called, so it's recording the odometry. Although sometimes well, it makes it's not very accurate. Sometimes it makes some mistakes. So in order to close the loop, well, I stated it has to be kind of a threshold, so it's not going to be in the exact point, but
Mm-hmm.
maybe around 40 centimeters or so, so half a meter or so. So it should be okay. It's not going to be perfect.
Yeah,
So
but
yes,
as long as it
it's going
does
to
one lap and okay,
yes.
yeah.
And it's, well, now the path seems to be a little bit smoother,
Mm-hmm.
but yes, so also I had to also kind of adjust the speed of the robot, because if it was going too fast, well, it also kind of didn't work that well, especially with those drastic turns that we already witnessed.
Okay, and oh, so depending on the velocity,
Hmm.
the so what would happen if it was too fast? It would.
Well, maybe what could happen is that, well, the turns would be very drastic, very fast, and maybe it wouldn't be able to correct as
I
quickly.
see.
So it's going to go to other parts of the circuit and not make the path that we're going to try and make follow.
I
Because
see.
every time it detects an obstacle or a wall, it's going to try and leave it on the right side. So if those posts that you can see in the center of the circuit, if it detects them as part of a wall or an obstacle, it's going to try and leave it on the right side of the robot.
Oh, I see. I see. I see.
So it could get lost sometimes.
Oh, it's getting close to the wall.
Well, and now it's outputting also what distance is from the beginning. So
Right. Right. Right.
uh,
Right.
when when that variable is less than, I think I left more less than 0.4, it should consider loop complete,
Okay.
completed, and the goal has been succeeded. So that should be also, well, the whole loop.
Okay. Okay. Okay.
So I also have kind of some slides to maybe explain better some of the aspects of the robot. It, do you see the change to from the browser to the slides, or
No, I don't see it. Did you do
okay?
it already?
Um, should be
Oh,
now.
I see it now. I see it now.
So just to explain some, guys, maybe we can go kind of quickly on this part because we've already seen kind of an example. But yes, so the main script has a class that is called topic controller, and there the publisher and subscriber are well, are defined. And also we have a timer that is going to have a callback, and in which the publisher is going to be, well, publishing the messages. So we can control how fast these messages go, and it's kind of a regular thing. It's not always going to be, it's kind of, yeah. So, and the main this main script, how it controls the robot is, well, it collects the data first of all in the topic callback, and because it was arranged, so with this particular mathematical function we can get the value for each angle. Then with that data, we kind of define some behaviors that they're going to define the variables that control the movement of the robot. We have turn that decides if the robot has to turn and how quickly from right to left, and vel that determines how fast the robot should move forward. So we have three kind of behaviors. If the robot is not on track, it's going to turn, well, the speed is going to be constant, and it's going to turn closer or farther away from the wall. If the robot is on track, it's trying to minimize the difference between the front right direction or measure and the back right measure. So it's going to try and go in a parallel direction from the wall and the back. And right. Lastly, if a wall is found, it's going to reduce the speed and it's going to turn until the distance in front of it is more than 0.6. So it should be free to go. So, and in this timer callback, we also have, if the position is not initial, if the pose is not initialized, it should ask for the service to do it. If the action that records the odometry is not called, it's going to call it. We also we have a threshold, so the values that the messages can output are not too large to just make safer the robot. And finally, publish the message. We also, in the same kind of way, we also have another script that, in the main script, we also have a client service with the custom interface that asks for the initialization. And in another script, we advertise the service, and we make a class that makes this particular movement. When this is already done, or when the pose is initialized, the response is a true value. And this was kind of an issue I had trying this particular part of the code, because in the simulation, two objects were kind of at the same distance. So the robot keeps spinning, trying to face one and face the other. So it didn't initialize at all the pose. So what I did to correct this is choose a direction for the closest object, and just analyze the, let's say, a focus area. So it's going to analyze a range around it. It's not going to, so as long, as soon as it has a mean value, it's going to just try to focus on that direction. And if another thing gets closer from another direction, it's not going to notice it at all.
Oh, okay.
So this goes in 3 steps. First step is facing the wall of the closest object, then trying to move forward until it's left at 0.5. And lastly, it's going to leave that object to the right side. After that, the whole loop should be completed. Well, here I have a video of the simulation, but we kind of also seen this behavior in the real robot.
In the real robot, yeah.
Yes, but
I see what you're saying about the two objects.
Yes, those two signals were very close, and when the robot was spinning, one was considered closer to the other, and when it faced the other one, it happened with the first. So it didn't initialize at all the pose.
Right.
And the client works in a similar way. We have the action. So we have the action client in the main script, and we also make another script that is going to be the action server. Here in the execution, we have a subscription also that is going to update the values for X, Y, and Zeta. That makes a conversion from from quaternion to Euler angles. And also in the execution callback function from the action, we loop that function every second, and we're going to push those values that's been updated from X, Y, and Zeta to a vector of points.
Okay.
So every second is going to be added a new point in there.
Right.
After that, we calculate the distance by adding the difference between points in the vector. And so this was for the feedback, because it was stated that we needed to output the distance of the robot that has been already been run. And lastly, after a threshold of distance, because we're not going to try and see if the loop is closed from the beginning, we check if the first point and the last point are in less than a threshold. And if If that's the case, the loop is going to be considered completed. And well, this what well in the simulation, as we could see in the real robot, um, we kind of output in the terminal
Yes.
the distance from the beginning, and when it's less than 0.4, it's going to be completed. So here we have the video sped up from the simulation, but as said, we already kind of seen this how it works.
Yeah, yeah.
Um,
And this threshold checking, that's within the action server, correct?
yes, it's inside of the action server, so it takes care of the whole recording of the odometry.
Okay, okay.
So it just gives a response that is going to be if the action is finished or not. Oh well, here another interesting thing. So here, that particular sign in the road is going to be considered as an obstacle because it gets in the angle. So it's going to leave it on the right side, as said
Oh,
before.
okay.
So maybe a little more. It could be
Wow.
if we wanted to correct that, maybe we could make a little more complex behavior. But for a start, I thought it was all right.
Yeah, and the fact that it keeps it on its right by like by itself is kind of nice. You know, it's taking into account an obstacle that is going to be considered on the right side of the road. Yeah, yeah.
And well, and also I have a video of the robot, but this is completely the same as the thing we saw before.
And
So that would be the end of the presentation. So if you have any question,
okay, great. Great. Yes, I do. Well, first of all, do you mind stopping sharing your screen
oh yes,
so we can get?
is that it has already ended the sharing of the screen?
Yes, 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 yes. I
Okay.
can see you. Let me just kind of fix it here. Well, first of all, congratulations. That's a really nice project you have here. And it's our first one in ROS2 C++ actually. So I just want to say congratulations, and that it's really clear. And we already saw that it works in the real robot as well as in the simulation. And I wanted to just comment on a couple of things I really liked. Well, that first part about the obstacle in the simulation, how it considers it part of the wall too, so it keeps it on its right. That's really nice actually. It's the first time I see that, so it's really nice to see. And I also like the fact that your program is adjusting the velocity, both the angular and the linear, correct? As
Yes.
depending on what happens and where the obstacles are. So I thought that was really interesting as well, because the first thing to the basic thing is to just send two commands, same, like an angular velocity with a certain value and a linear velocity, and just keep those constant. So I thought that was really nice. I do have a couple of questions. So the first question is, could you explain a little more about this initialized position within the service server? Because I didn't really understand that part of the that you talked about initializing a pose.
Yes. So inside of the service server, it has well, I made kind of a class turtle that basically is very similar to the main script. It has it subscribes to the laser topic, and also has the publish to the topic that controls the robot. So in that kind of way, it's just taking control from the main script and saying, okay, well, now with this information, I'm going to move the robot in just a particular set of very defined movements. I'm
Oh,
going to
okay.
try to face the wall, and afterwards I'm going to try to get closer if it's not close enough. And lastly, I'm going to try to leave those that close direction, for saying some way, in the right size. So I'm going to make it the same value.
Okay, so you're talking about the post being initialized once it's found the wall and it has been sort of put on the right position so it can start the loop.
Yes. So
Okay.
that's the first thing the program checks is just call the service, and if the service says, okay, well, I can guarantee that the robot can go on from this point, and is the point where the main script is going to take control of the robot.
Oh, okay. I see. So that way
You
there's a
can
scenario.
guarantee always, yes, that the controller is going to move in the same behavior. It's not going to make weird things in the
Right.
beginning.
Did you ever run into a scenario where that post couldn't be initialized, sort of, and your program wouldn't be able to start because the main script would never take over?
I think, well, I didn't encounter that particular case. Just, well, when two objects were considered very close and I didn't have the distinction, the robot just spinned the whole time
Yeah, that's
because
what you showed me.
it
Okay.
couldn't. So I would say that's the only case I've encountered that the robot didn't start the main script movement, for saying in some kind of way.
Okay. And the other thing I wanted to ask was, so what happens if the action does not return a success? So did it ever happen to you that the the whole movement got interrupted somehow and the action didn't return a success? Is there a scenario to account for that?
Well, if the robot gets lost, uh, I think the action could encounter some kind of a scenario of if the robot is stuck in some point or to a wall or something like that. It could encounter a scenario where the robot doesn't end the action. But in that way, well, the robot just would keep moving along the
Until,
road.
okay, move forever until it gets to that threshold you talked about, and then
Yes.
the action will be completed. Oh, okay. So that's pretty. That's a pretty bulletproof program you got here. So um, that's it. That's all the questions I have. So again, congratulations, and you're the first one to do this in C++ in ROS2. So we hope that we're going to see you tackle a couple more of those if you want and if you're interested. And I saw that all three sections worked as in the simulation as well as in the real robot. So in that regard, like in terms of your evaluation, you have like a full score. So because everything worked and it was really clear and your presentation was very concise and clear. So congratulations, Guillermo. That's all for me. So uh, just great job.
Thank you very much. I did like a lot the course. I think it was very well explained, and I really like the feature of having a real robot to connect to and try the main code. It
Oh,
was it was. I think it meant a lot in order to understand better how it worked and the limitations I could have in a real robot. So I think it was very good,
oh
a
well.
very nice experience.
Well, thank you very much. That's our main goal here to have a good experience in the course and with this added options that you have with the real robot, so you can test your programs. And so this is to everyone else watching. This could be you, and you have all these tools that you can have in order to get started with ROS2 in C++. So I invite you guys to follow Guillermo's lead here and continue learning ROS. If that's everything, then that's all from our side here at the Becoming a ROS Developer channel. And thank you very much, Guillermo, and we'll see you next time.
Thank you very much.
Okay, bye-bye. Bye, you guys.
Bye.